Well, again, let's take a look at the concepts of binomial expansion. Binomial expansion. What that is basically you're taking a binomial, which is a polynomial of two terms, and you're taking it to a certain power, right? So, for example, let's say I want you to calculate something like 2x plus 3 quantity to the fourth power, right? Now, this is a very long calculation for us because this is multiplying out 2x plus 3 4 times, right? So this is going to be 2x plus 3 times 2x plus 3 times 2x plus 3. That's a 3 there, sorry about that. 2x plus 3. And finally, the 2x plus 3, the fourth one. Alright, so we have to multiply out 4 2x plus 3s, which can be quite time consuming if we're going from left to right and working it out step by step. There's a better way to expand this without doing that. However, even then, it's still not an easy problem to work out, all right? But anyways, we're going to use what's called the binomial theorem to expand this, all right? Now, before we get into that theorem, though, let's give you some background information involving it, because we're going to need these concepts in the binomial expansion here, all right? So let's first thing to look at is the factorial of a number. Let's take a look at what's called the factorial of a number. Okay, so we're not going to multiply out the 4 2x plus 3s here, right? We'll use the binomial theorem instead later on, all right? But let's take a look at the factorial of a number, though, in terms of that, to add some background information here first, right? So what is that? What is the factorial of a number? Well, the factorial of a number is simply a number that's going to be multiplied to numbers successively less than it, all right? So this only applies to whole numbers here, all right? Actually, only whole numbers. So, for example, let's say I want you to find 5 factorial. Okay, so we use the exclamation mark point to signify factorial. So we should read this in English as 5 factorial. All right. Now, how is this defined? Well, this is defined as the product of 5 and all the whole numbers less than 5, except 0, of course, right? So maybe I should say natural numbers, perhaps, right? So we're not including 0 because anything multiplied to 0 is going to be what? It's going to be 0, right? But 5 factorial is going to be defined as 5 times 4 times 3 times 2 times 1, all right? So if we work that out, that's going to be what? 20 times 6, right? Which is 120. All right, so these numbers can get big in a hurry because you're multiplying a bunch of numbers, right? So now we don't have to do that by hand. We could simply use the factorial key on our calculator. All right, factorial key on our calculator. So if I say let's go ahead and calculate, let's say 10 factorial. This is defined as what? A product of 10 and all the natural numbers less than 10. So 9, 8, 7. 6, 5, 4, 3, 2, and 1. All right. So what is that equal to? Well, instead of punching all these numbers into the calculator, this would be a really big number. Let's just punch it in using the factorial feature on our calculator. So look for this feature on your calculator here. All right. So I'm going to punch it in. So on my calculator, I have to punch it. I have to enter number 10, and then I'll hit the factorial feature. And then that should give it to me right away without hitting the equal sign. So 10, you may have to hit the equal sign on your calculator. So it depends on your calculator, but know how to work this factorial feature on your calculator. So 10 factorial. So I need to hit the shift key on my calculator to get this feature. So sometimes you may need the shift key or the second key, right? Shift or the second key. It depends on your calculator once again, right? So 10 factorial. So if I use that feature, here's what I get. I get 3628800. So 3628800. Let me write that a little bit better with the commas here. So this is what? 3,628,800. That's a pretty big number, obviously, right? So these numbers get big in a hurry because you're multiplying a bunch of numbers together, all right? So again, the factorial of a number is what? It's defined as what? The product of the number and all the whole numbers that are all the natural numbers that are less than it. So all the way down to 1, you're going to multiply by. So these numbers again get big in a hurry, but use the factorial feature on your calculator to figure that to do the calculation instead of doing it all by hand and punching it in number by number. All right. So let's take a look at then the and another concept here. Then let me go and clear out the screen. All right. So let's calculate. Let's do some calculations with factorials then, right? For example, let's say I want you to calculate something like 8 factorial divided by 5 factorial. Let's do some factorial calculations. Again, we can do it all by calculator, but I just want to show you some concepts by hand. This is what 8 times 7 times 6 times 5, 4, 3, 2, 1 by the factorial definition, right? And we did this one earlier. This is 120, right? But let's write it out. 5 times 4 times 3 times 2 times 1. But as you can see, if you're dividing this, you see that how the 5s can cancel out, the 4s can cancel out, the 3s can cancel out, the 2s, obviously we can just leave off the 1s, right? But this is nothing more than 8 times 7 times 6, if we, which we can then punch into the calculator, right? So 8 times 7 times 6, which is 336. All right, so not too hard if we think about the factorials, but the shortcut I want to show you is this. Look at 8 factorial again. 8 times 7 times 6, and then 5, 4, 3, 2, 1. So this 5, 4, 3, 2, 1, I could have written as 5 factorial. In other words, I could have done this calculation as 8 times 7 times 6 times 5 factorial instead of 5, 4, 3, 2, 1 divided by 5 factorial. That can cancel the 2 5 factorials. And I still get the 8 times 7 times 6, which is going to be the same result as the 336. All right? So we can do that as a shortcut if we're doing it by hand, for example, and partially by hand, partially by calculator in this case, right? Let's take a look at something like 12 factorial divided by 9 factorial. All right? So this is going to be, what, 12 times 11 times 10 times 9, 8, 7, all the way down to 1. But again, that's going to be, what, 9 factorial, if you will, right? Divided by 9 factorial, so I'm just going to cancel out the 9 factorials. Can we see that? So this is the shortcut we're talking about. So here I'm just multiplying out, 12 times 11 times 10. 12 times 11 is 132 times 10, that's going to be 1320. All right, so we're okay on that. So hopefully not too bad in terms of using this little trick to do calculations with factorials here. All right. Now let's talk about another concept that we haven't seen in the past. Let me go and clear up the screen. Let's talk about the concept of combinations here. Let's look at the concept of combinations. All right. Combinations is based on factorials, actually. All right. But before we get into that, let me give you the format for combinations. Combinations are written this way here. It's written as a big parentheses and n on top and k on the bottom and a big close parentheses. Right now, first of all, what does this mean? Well, let me go ahead and tell you how you should say that in English. This is going to be n choose k. N choose k. So written this way, it's a combination called n choose k. So what does this mean, n choose k? It means that if I have n objects, so suppose I have n objects, n objects in some kind of set, I'm going to choose k objects out of that. Choose k objects. So we're assuming obviously that n is greater than k because you have more objects. You're choosing a subset of those objects. So let's say I have 5 objects and I choose 3 of them, right? So this little combination here tells me how many different combinations are possible. So this is equal to the number of combinations possible if there are n objects and we choose k of them, and we choose k of them. All right, so keep this concept in mind. Again, n choose k means what? So we're going to read this as n choose k, so the bigger number on top, smaller number on the bottom. Okay, so we have n objects, we're choosing k objects from those n objects. How many different combinations are possible? Well, it's defined by this little notation here called combinations. All right, now how do we define this combination here? Well, we're going to define this using what? Using factorials. All right, so here's the definition here. All right. N choose k is going to be defined as n factorial over k factorial. We did some calculations like that earlier, right? But also times n minus k factorial. So this is the definition to keep in mind here. All right. So if I'm doing a calculation here, then let's say I have earlier I gave you what? Let's suppose we have 5 objects. I'm choosing k of them. How many different combinations are possible? Well, let's do that calculation here. Let's calculate 5 choose 3. Again, read this in English as 5 choose 3. So you have 5 objects, you're choosing 3 of them. How many different combinations are possible? Well, let's use this definition here. So n choose k is defined as what? N factorial. So it's going to be, there's my n, right? There's my k, right? So n is equal to 5 here, k is equal to 3. So therefore we have 5 factorial divided by k factorial. So 3 factorial times what? N minus k, or 5 minus 3 factorial. Now you can skip this step and say just 2 factorial. That's fine, because these two numbers down here will always add up to the 5 on top. So this is going to be 5 factorial over 3 factorial times 2 factorial. Can we see that? Now let's do this calculation here then, right? So I can write this as 5 times 4 times 3 factorial, right? Because I want to cancel this 3 down here, right? Divided by 3 factorial. 2 factorial is going to be 2 times 1, right? So the 3 factorials cancel out. So this is going to be what? 5 times 4 divided by 2. So let me cancel the 2 with the 4 to get 2 up here, right? Can we see that? 2 and the 4 twice. So 5 times 2 is going to be what? 10. So there are 10 different combinations possible if I have 5 objects and I'm choosing 3 of them. Okay, does that make sense? Can we see that? One more definition I want to give you. Let me go and clear off the screen before we do some more example of combinations here. Is that another definition I want to give you here is that you can punch this into the calculator to verify using the factorial button. But 0 factorial is equal to 1. Okay, so keep this definition in mind. All right, but let's do some more combinations. Suppose I have let's say I have 51 choose 6. All right, let's say I have some kind of lottery where you have 51 different numbers, and you choose 6 of them. If you pick all 6, obviously you win the lottery. So how many different combinations are possible? Obviously in this little setup. Well, again, let's use the factorial definition for this. Right, this is 51 factorial. Okay, so this again, there's my n. N is going to be 51, right? And my k is going to be 6 down here, right? So divided by what? 6 factorial. And then what's 51 minus 6? That's what? 45 factorial. Can we see that? Just subtract these two to get the next number, right? Instead of showing all the work like we did in the last problem. All right? Again, these two numbers have to add up to what? 51, bottom line. All right, so how do we calculate this? Well, let me write 51 times 50 times 49 times 48, 47, 46, and then I'll stop right here at 45 factorial, running out of space there, sorry about that, right close to the edge, hopefully you can still see it. But divided by what? 6 factorial, that's going to be, I'll just punch this into my calculator here. 6 factorial on my calculator is going to be what? 6 times 5 times 4 all the way down to 1, right? So again, just use the factorial key in your calculator. I get 720. 720. So this is going to be 720. This is the 6 factorial. Now 45 factorial, I'm just going to write it as 45 factorial because I'm going to cancel it with this 45 factorial on the top. Can we see that? These two cancel out. So this will give me what? Let me punch this in carefully on my calculator. So 51 times 50 times 49 times 48 times 47 times 46 equal to a very big number, all right? But I'm going to divide it by 720. All right? So this is what I get. I get 1800, all right, 9460. 9460. So let's see. Let me get that 0 in there. Sorry for sketchpad here. All right, that's over 18 million different combinations. Can we see that's 18,009,460 combinations here are possible. If there's a lottery of 51 numbers and you have to pick 6 of them, so there's over 18 million combinations. Now with our current lottery, the combinations are even more than that, right? So it's even more complicated than this. So again, know how to calculate the combinations here using that definition we gave earlier. All right. Now, fortunately though, this is still quite a bit of work. I have to punch all this in and divide by 720. It's still some work for me on the calculator, nevertheless, right? However, there's a feature on our calculator called NCR. NCR looks something like that on your calculator, right? Look for this feature. Again, you may have to hit the shift key or the second key to get this feature, but this will give it to you right away instead of doing all this work. So in other words, if I were to ask you to find something like, let's find 15, choose 7. Let's say I have 15 objects, I'm choosing 7. How many different combinations are possible? Again, if I have to write it out, it would be 15 factorial over 7 factorial. 15 minus 7 is what? 8 factorial. But again, I'm not going to do this calculation by hand. I'll just use this NCR feature on my calculator. All right. So what's that going to give me? Again, I'll punch it in. So I'll go 15. So here's how I punch it in. I'll punch in 15 first. I'll hit the NCR button, and then I'll hit 7, and I'll hit the equal sign. Okay, it depends on how your calculator works to get this. Each calculator works differently, so you have to figure out how to use this feature, bottom line. All right. So my calculator will be 15, shift NC to get the NCR feature, and then 7, and then hit the equal sign. You get 6,435 combinations. All right. So again, use this NCR feature to come up with the answer instead of doing all this calculation with the calculator. All right, so use this button on your calculator. Use this feature. Know how to work this feature on your calculator. Bottom line. Let's do one more. Let's take a look at something like 21. Choose. Let's say choose 4. 21 numbers. Choose 4 of them. How many different combinations are possible? Again, I'll punch it in. 21. NCR 4 equal sign. All right. So 21. NCR 4 equal sign, I get 5,985 different combinations when I have 21 objects and I'm choosing 4 of them. All right. So again, these numbers do get big in a hurry, but we need to know how to work these combinations in terms of the calculation, because the binomial theorem is based on that. So let's go and get right to the our original problem of how to multiply out a binomial if it's such as 2x plus 3 to the 4th power, right? Let's get back to that problem. All right, let me go and clear out the screen. So earlier we had this problem of 2x plus 3 to the 4th power, right? And we didn't want to multiply out the 4 2x plus 3's. So I want to use what's called the binomial theorem instead, all right? Now, before I get into that theorem, though, all right, let's figure out how many terms are going to be in this expansion. But before we get into that, let's take a look at some formulas we've seen in the past. Let's look at something like a plus b. So this is a plus b, 2 general terms, right? That's a binomial, right? Let's take it to the 0 power. Now, if you recall, anything to the 0 power is simply 1, right? Can we see that? If I take a plus b to the 1st power, it'll be what? Just a plus b. Anything to the 1st power is itself, right? A plus b. What about a plus b quantity squared? Well, we've seen that formula before, right? Isn't that a squared plus 2ab plus b squared, right? We've seen this perfect square formula in the past. But look, let's stop right here, because if you take it to the 0 power, you have what? 1 term. If you take it to the 1st power, you have what? 2 terms. Take it to the 2nd power, excuse me, there are 3 terms. So if you take it to the nth power, this is what we're trying to do here, right? Take it to any power, right? How many terms are going to be? Well, look at the power and look at how many terms. The number of terms is always what? 1 more than the power itself. Can we see that? Square it, you get 3 terms. So if you take it to the nth power, you're going to have what? N plus 1 terms. Does that make sense? All right, hopefully you can see that. Now what about this 2x plus 3 to the 4th? How many terms? Well, it's going to have what? Has what? 5, n plus 1, right? 4 plus 1, so 5 terms. there's going to be 5 terms when I multiply it all out and combine like terms, right? So we should get 5 terms for this expansion. All right, now let's take a look at then this expansion then, right? So here it is, right? So a plus b to the nth power, all right? Here's the definition. This is going to be, so a plus b to the nth power, this is going to be the sum, let me write it a little better, the sum of k going from 0 to n, so we're going to run k from 0 through n, so you have to plug in k from 0 through n, right, all the way up to this power, in other words, right, in this case it will be 0 to 4, right, of what, n choose k, right, so we've seen this combination before, discussed earlier, right, and so a is the first term, b is the second term, right, we're going to take a to the n minus k power, so the power of a is going to be what? Power of the first term will be what? The difference of these two numbers in the combination. The power of b will be the same as the lower number, the k, in the combination. All right. So the powers of a and b is based on this combination here. Again, what's the power of the first term? A is my first term, b is my second term, right? The power of the first term will be what? The difference of these two numbers. The power of the second term will be the same as the lower number. All right. So let's apply this theorem right here. So this is the binomial theorem. Let's apply this to the 2x plus 3 to the 4th power. Let me go and clear out the screen. So we're trying to expand 2x plus 3 to the fourth power. All right. So my a is going to be the 2x. Can we see that first term? My b is going to be what? 3, the second term. Right? Now, according to the theorem I wrote down earlier, this will be the sum of k going from 0 to what? Well, n is what? 4, right? So n is equal to 4 in this case. Probably should write that down as well. So up to 4 of what? 4 choose k, or n choose k, right? So 4 is n, and 4 choose k of what? Of 2x, right? A is the first term, 2x to the what? 4 minus k, and what else? 3 is the second term, so 3 to the what? Same as the lower number, the k. All right. Now, how do we write this out? Remember, this has to do with series, right? This is adding terms together. So I need to run k from 0 to 4, and that's how we get the 5 terms. But let's do that. Let's let k be 0. So let's start with k being 0. All right. So for k equals 0, what do we have? We're going to have 4 choose 0, right? Can we see that when k is 0? Okay. 2x to the what? 4 minus 0. So we're going to have 2x to the 4 minus 0. All right. And 3 to the what? 0, right? Because k is 0 here to start with, right? So 3 to the 0 power. All right. Plus, right? Because we're adding, this is sum, right? Plus what? Well, now let's have what? 4 choose 1, because now k is going to be 1 for the next term. And what do you have? 2x to the what? 4 minus what? Instead of 4 minus 0, it would be what? Now 4 minus 1. So again, the power of the first term, key concept here. Power of the first term is always what? The difference of these two numbers. 4 minus 1. Now you can skip this step and say 3 if you want to. That's fine. But I'm showing you step by step. All right. And 3 is the second term, so 3 to what? 3 to the first power. Same as the lower number. Power of the second term, again, key concept. Same as the lower number of the combination. So 3 to the first power. Plus, what's the third term? Well, third term is 4 choose what? 2. Now k is now 2 in the third term. All right. So first term k is 0. Second term k is 1. Third term k is 2. All right. So what is the power is going to be? Well, it'll be 2x to the 4 minus 2 and 3 to the second power. All right. Let's continue. What's the next term going to be? Well, next k is going to be what? 3, right? So 4 choose 3 now. All right. K is equal to 3 now, right, for this fourth term. 2x to the what? 4 minus 3. The power of the first term is always the difference of these two numbers. 3 to what power? Same as this lower number. 3 cubed, or 27 if you want to skip a step there. It's up to you. And lastly, k is now at 4, right? K is 4. This is now the fifth term, right? In this expansion. Again, there are 5 terms here, right, in this answer. So this will be what? 2x to the 4 minus 4, or 0 if you like, and 3 to the 4th power to finish out. All right. Now we have to work all this out term by term. So, but that's not hard. We have the NCR feature to do this, right? So this is going to be what? Just punch in for NCR 0 on your calculator. This is going to be 1. If I punch into the calculator, for NCR 0 equal sign, that's 1. All right. What's 2x to the 4th power? Well, it'll be 2x to the 4th power. I'm going to work that out later on. All right. 3 to the 0 is 1. So I'm just going to put a 1 there for 3 to the 0. Right. There's the first term. Excuse me. All right. Plus. Pretty long problem there, huh? All right. 4 choose 1. That's going to be 4 if I punch it into the calculator using the NCR feature. All right. 4 NCR 1. Right. That's 4. 2x to the what? 4 minus 1 is 3. So 2x cubed. Can we see that? And 3 to the 1st power is just 3. All right. Second term. All right. Third term. 4 choose 2. Punch it in. 4 NCR 2. That's going to be 6. So that's going to be 6. All right, 4 NCR 2. This is 6 here. 2x squared. Second power, right? Because 4 minus 2. And 3 squared, again, that's going to be 9. But I'm just going to bring it down if you don't mind. All right. 3 squared. All right. All right. Finally, actually a couple more terms to go. 4 choose 3. And 4 NCR 3 is going to be 4 as well. You're running out of space here. But 2x to the 1st power, 4 minus 3, right? 3 cubed. Right, 27, but I'm just going to put 3 cubed there if you don't mind. All right, and the 5th term here, 4 choose 4, 4 NCR 4 on my calculator is going to be what? 1. If I punch this in the calculator again, use the NCR feature, right? 2x to the what? 0 power. And 3 to the 4th. Okay, so work these terms out, work these calculations out step by step. Do each combination, one combination at a time, right? Using the NCR button in your calculator, and just take these to the powers next, right? So what do we get here? Well, what is 2x to the 4th? 2 to the 4th is what? 16, right? So 16 x to the 4th. There's the first term, because times 1, that's not going to matter, right? Plus 4 times 3 is going to be 12, but I'll just bring it down. That's fine. 4 times what? 8. 2 cubed is 8, right? So 8x cubed times 3, all right? We'll work this out later on. 6 here, so plus 6 times what? 2x squared is what? 4x squared. Let's work it out step by step. What's 3 squared? 9. Right, can we see that? Plus 4 times 2x. What's 3 cubed here? 3 cubed, that's a 3 there. Sorry about that. 3 cubed is 27. 27, can we see that? All right. And last but not least here, 1. I'll just leave off the 1. And what's 2x to the 0? That's 1 also, right? Well, I'll just put it in, right? 1 here, 2x to the 0 is 1. 3 to the 4th is what? 81 if I punch in the calculator, all right? Okay, so we have 1, 2, 3, 4, 5, right? 5, there's my 5 terms. Let's finish it off. So 16x to the 4th. So these problems are pretty tedious, even with the binomial theorem. But if you try to multiply out all 4 2x plus 3, it'll take even longer, in my opinion. All right, so plus what? Let's work it out. 4 times 3 is 12 times 8. So 12 times 8 is what? 96 x cubed. 6 times 4 times 9. So I'll punch the calculator. 24 times 9. 216. 216x squared. Third term. Fourth term. 8 times 27. 8 times 27 plus 4 times 2 is 8, right? 216 again. Plus 216x plus what? 81. Alright? So we're saying that if I multiply out the 4 2x plus 3's, I'm going to get this polynomial of 5 terms. Alright? It's pretty tedious, as you can see, but using the binomial theorem is going to work out. Let's try another one here. Let me go and clear off the screen. Alright? Let's take a look at something like 4x minus 3y quantity cubed, right? So we'll just drop it down to make it more manageable for us. So probably on the final fun exam, probably give you up to 4th power, because that's these calculations can be quite tedious, obviously, right? All right, so let's write down the a. First term is what? 4x. Second term, negative 3y, I should say, right? Because a plus b, the formula is based on a plus b, so b should be negative 3y. Be careful there, right? So don't say 3y, it should be negative 3y. All right, what's n? Sorry about that. N is what? 3. All right, so let's write down the sigma notation then. K going from 0 to what? 3 in this case, my n, right? 3 choose k. of what? 4x to the 3 minus k. Again, first term. It's always, the power is always difference of these two numbers. And negative 3y, same as the lower number k. Alright? Now we have to write this out. How many terms, by the way? Well, again, take it to the third power, there should be what? 4 terms. Right? So we're running k from 0 to 3, should be 4 terms. Alright, let's go write it out. That's going to be, so when k is 0, we'll get what? 3 choose 0. Alright? When k is starting at 0, right? 4x to the 3. Now I'm going to skip this. 3 minus 0 is going to be 3, so I'm just going to say 4x cubed if you don't mind. And negative 3y to the 0 power plus 3 choose what? 1 is next time is k is 1 for next term, right? For the second term. Alright? So this is when k is 0 for the first term, k is 1 for the second term. And this will be 4x to the what? 3 minus 1, or how about square, right? 3 minus 1. I'm just going to work that on my head if you don't mind. And negative 3y to the what? First power. Same as the lower number in the combination. First power. Alright? What's the third term? Well, third term k is now equal to 2 for the third term, right? So we have 3 choose 2. Alright? And it's going to be what? 4x to the 3 minus 2 is 1. So 1 power, right? Or just 4x if you will, right? That's a 1 there. And negative 3y what? Squared. Alright? And lastly, the fourth term, now k is equal to 3 for the fourth term. So 3 choose 3. So last number up to 3, right? So it'll be 4x to the 0 power, right? Because 3 minus 3. And negative 3y cubed. Can we see that? So we have these 4 terms to work out now. Let's work it out term by term. Use the NCR feature. 3 choose 0 is 1. Actually, there's a theorem that says that a number choose 0 is always going to be 1. Alright? So, but calculator will confirm it. Just use your calculator. Alright, 4x cubed is going to be what? What's 4 cubed? 64x cubed. Negative 3y to the 0 power, that's just 1. Plus 3 choose 1 is going to be 3. You punch in the calculator. Alright, NCR. 4x squared is going to be 16. X squared. Alright. And negative 3y to the first power is simply going to be negative 3y. Alright, this is the second term. Alright, third term, 3 choose 2 is going to be 3 as well by punching the calculator, NCR. 4x, alright, 4x to the first power is 4x. But what's negative 3y squared? Is positive 9y squared. Can we see that? Alright, positive 9y squared. When you square the negative number, it's positive. 3 choose 3 again is 1 by punching the calculator. 4x to the 0 power is also 1 to the 0 power. And what's negative 3 to third power? That's going to be negative 27y cubed. Can we see that? Alright, let's finish it out. So this is going to be what? 64x cubed. So these are tedious problems here, obviously, even with the binomial theorem, right? What else here? 3 times negative 3 is going to be negative 9 times 16. So negative 9 times 16 is going to be negative 144. So negative 144, what? X squared y, right? X squared and y here, right? And what's the third term going to be? 3 times 4 is 12. 12 times 9 is 108. So plus 108 xy squared. Xy squared. Third term. Last term is going to be what? Negative 27y cubed. So these are the 4 terms we get if we times out 3 of these binomials. All right. Now I want you to notice something else. So obviously these problems are tedious, right? But if I ask you to find a certain term in the binomial expansion, you can certainly do it. Because, for example, let's say I give you this problem. Let's say, all right, what is the third term? Well, here's the first term, here's the second term, here's the third term. So you're just going to find this term here, which is not that bad since you're just finding one term. The key, though, is to see what k is going to be in that case, right? Well, you can see for the third term, the k is always 1 less than the term you're trying to find. So it's going to be what? K is going to be 2 for the third term. All right. So here's what I mean by that. Let me go and clear out the screen. Let me say let's say the kth term. All right. Let's say I want you to find the kth term of a plus b to the nth power, right? Some binomial to the nth power is going to be equal to what? N choose what? Not k, right? K is always going. The k will be 1 less than that actually, right? So k minus 1, all right. And then the powers will be the same. Just the difference of these two, n minus k minus 1, b to the what? Same as the lower number k minus 1. All right, but don't try to memorize these powers. Again, it's the same concept as before. The power of the first term is always what? Difference of these two numbers. Power of the second term, same as the lower number. Right? So if I give you this problem, for example, let's say I have something like 2x plus 3 to the 8th power. Right? Obviously, that's a very long problem. There's 9 terms here if I work it all out. So I don't want you to find all 9 terms. I just want you to find the 6th term. Find the 6th term in the binomial expansion. All right. So therefore, this is going to be what? So my a again is 2x. My b is what? 3. My n is equal to 8. All right. So it's going to be what? 8 choose what? Not 6, right? It's always one less than that. So choose 5. Can we see that? So here, down here should be a 5. Okay. Key concept. Right. 6th term, k is 5 to get the 6th term. All right. But the rest is the same, right? It's going to be what? 2x to the what? 8 minus 5 is going to be 3, and 3 to the what? 5th power. Can we see that? So you can certainly find any term in a sequence if you use this concept correctly here, right? So again, the key is what? The number in the lower number is going to be one less than the term you're trying to find. 6th term, k is 5. All right, let's work it out. What's 8 choose 5? So 8 NCR5 on my calculator is 56. So this is going to be 56. All right, this is from the calculator. 8 NCR, using the NCR feature again. 2x cubed is going to be what? That's 8, right? 8x cubed. All right. What's 3 to the 5th? 3 to the 5th power on my calculator will give me 243. Okay, so final answer is going to be 56 times 8 times 243. Pretty big number. 108,864. So 108,864 x cubed. So this is the 6th term in the binomial expansion. All right. So again, to find one single term is not hard at all. You simply choose a number that's one less than the term itself. Let's do one more. Let's take a look at something like the one we had earlier, 4x minus 3y, but this time. All right, so 4x minus 3y, let's make it to the 15th power, all right? And I just want you to find the, let's say the 12th term. Find the 12th term in the expansion, all right? So again, what is the thing that the a, b, and the n going to be? Well, a is going to be 4x again, first term. B is going to be negative 3y, second term. My n is going to be 15, right? So therefore, it's going to be 15. Choose what? Again, we choose one less than the term we're trying to find. 11, right? 15, choose 11. So it'll be what? 4x to the what? 15 minus 11 is what? 4th power. Negative 3y. B to the what? Same as the lower number. You know, that's going to be a pretty big number there, right? Okay, so can we see that? All right, hopefully my calculator won't give me a scientific answer on that. So let me see if it does, actually. Let me just try it real quickly. Hopefully, okay, we didn't. Good, thank goodness. All right, let's go ahead and work it out then. So let's see what we get here. So 15 NCR11, what's that going to be? So 15 NCR11, hopefully not too big. Okay, 1365, not too bad. 1,365. 4 to the 4th power in the calculator, that's going to be a pretty big number as well. 256. X to the 4th power, right? Can we see that? And what about this one here? Negative 3, so negative 3 to the 11th power is going to be negative 177,147. So negative 177,147, or negative 177,147, excuse me, y to the what? 11th power. Okay, so pretty big numbers here. Let's see how this turns out on my calculator. Hopefully it won't give me scientific notation, because since if I run out of space, it'll give that to me on my calculator. Times 1365 times 256. Ah, darn it, it gave me the number in scientific notation. So so I'm just going to have to write it out here. Let's see. Negative 6. Here's what it gives me on my calculator. Negative 6.19 022 022 4 768 times 10 to the 10th power. Oops, 10th power. That's a huge number. But bottom line is, I'm just timesing these three numbers here. They're big, but so I apologize for that. But it's going to be what? X, but it's going to be negative. Keep that in mind, though, right? X to the 4th y to the 11th. All right. So again, sorry for this number in the scientific notation. This was from the calculus. This is not an x here. Right? This is the scientific notation. This is the coefficient here of this term. All right. So well, if I move it, let me try to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually, there's a missing number as well. So the calculator couldn't quite fit it in to the entire screen. Yeah, these numbers get big in a hurry, obviously, with the combinations and the exponents here, right? So this is really not the complete accurate answer because of this number given to me by the calculator. This number right here in scientific notation, all right? But you get the idea, right? Again, to find a certain term, you simply choose one less than the term number itself. Bottom line. All right. There are no Blackboard postings for this section, so study up on the material and do the homework, and we'll go over it in class. All right. So until next time.